Namaskar and welcome to this lecture 40, which is also the last lecture in this course on hydration, porosity and strength of cementitious materials. And today we will talk about the evaluation in this course, do some problems and also go through the entire course content in a nutshell. Now, coming to the overview, we will review our understanding through some questions from home assignments and a few others. We will have a summary of the topics that we have covered in this course, and there will be some closing remarks from us. Now, coming to the first part of it, this is where we started. Use this picture of concrete as a basis, converted this to this as a model, converted this to this as another model, a more simplified version where all these gravel particles are lumped together, sand is at one place, tried to do the proportioning of this mix using absolute volumes of the constituent elements, gravel, sand, cement and water, and there was air content. And then we started using this model for concrete in terms of a two-phase system, where we said that concrete comprises of aggregates suspended in cement paste matrix, and the cement paste matrix itself has voids and solids. So, now this problem was dealt with throughout this course with emphasis on cementitious materials, the hydration product, the hydration products, the hydration processes and so on. So, now let us try to look at some of the problems that we did in this course, and also some of the problems which were given in the assignments, and some of the problems which may be asked in an examination or a viewpoint which you should be aware of. So, coming to the first such example, this is the example of the mix of concrete that was used in the demonstration. We used a unit water content of 180, a cement content of 327, sand of 620 and coarse aggregate of 1264 kgs a cubic meter. And we reduced this whole thing to 550 grams of water, 1000 grams of cement, 1890 grams of sand and 3900 grams of coarse aggregate, mixed the concrete and showed you how the properties of the fresh concrete were actually evolving. We looked at the water, then we looked at the paste, then we looked at mortar, and finally we looked at concrete. Now, this was keeping this understanding, that is the paste, mortar and coarse aggregate division or constitution of concrete in mind, and these were the numbers which I showed you. Now, what I would expect is that you should be able to carry out this exercise yourself and also try to do a design of a concrete mix given the properties or given the requirements in terms of the water content, the water cement ratio and so on, not only from the strength point of view, but also the durability and other requirements that we talked about towards the end of this course. Now, this is the example that we worked on. What we need to know is, in order to come to this point, what was the characteristic strength that is required, what is the water slump relationship so that we can get the water content, what is the strength water cement ratio relationship so that we can get the cement content, and what is the required S by A ratio or the mortar content so that we can divide the remaining space between sand and coarse aggregate. Of course, all this assumes that we know how much is the air content that we need to keep in our concrete, depending on whether we are having air entrained concrete or non-air entrained concrete and so on. Then there could be, of course, other parameters such as durability, which will require that no matter what the water cement ratio or the cement content is from this side, that is the strength side, what is the minimum required from durability standpoint. So, keeping these things in mind, we should be able to calculate the weights or the volumes of the paste, mortar, coarse aggregate, cement, and so on and so forth. So, now coming to the second example in terms of using a superplasticizer, and superplasticizer is just one example, and we have talked about so many other chemical admixtures as well. Now, if we use this as a reference mix where we are using 180 kgs of water, 360 kgs of cement, that means we are using a water cement ratio of 50%. We do not use any superplasticizer, and we get, let us say, 8 centimeters or 80 millimeters of slump, and we get 35 MPa of compressive strength. Using this as a reference, one of the options that we have when we try to use a superplasticizer is to add the superplasticizer without altering any of the either water or cement. Therefore, water cement ratio has remained at 50%. What that would result in is a concrete which has more slump, but the same strength because you have not altered the water cement ratio, and therefore, the primary function that we expect the superplasticizer to be discharging is that of plasticizing the mix. Another way of looking at it could be, we say that, well, we are happy with an 80 mm or 8 centimeter of slump, and therefore, we can reduce the water content. Let us say we are able to reduce it to 160. What that will result in is that we will get a water cement ratio which is less than 50%, and therefore, whereas the slump will become 80, the strength is likely to be higher than 35. And here this superplasticizer is now helping us get higher strength. Finally, here is an example that if we are happy with the strength level that we have, we can actually reduce the cement content to 320 because we are happy with the water cement ratio of 50%, and in that case what this superplasticizer has done is to help us reduce the cement content. Of course, as we reduce the cement content, the overall volume for the sand and the coarse aggregate increases, but those are cheaper materials, and therefore, we could be quite satisfied with that. So, there are different ways of using a superplasticizer, and there can be combinations of either reducing the water, reducing the cement, or trying to increase or decrease the slump that we have. Now, coming to another example, let us talk of aggregate properties which we have talked about in this course. Using the sieve analysis data provided, determine the fineness modulus of fine aggregate. Now, there is fine aggregate, and here we have given you some kind of data for the weight retained in or on different sieve sizes. Now, using this data, you are required to calculate the fineness modulus. Now, this table shows how this calculation has to be carried out. We know already the weight retained, and then we go to the percentages of that and convert that to cumulative weight retained and determine the fineness modulus based on this total here. So, what you have to be careful about is to see what are the sieve sizes that are actually to be taken into account when we are calculating the fineness modulus, and this calculation can be done for not only the fine aggregates, but also for coarse aggregates. Only thing we have to be careful is the sieve sizes or the set of sieve sizes that we use to calculate the fineness modulus. Fineness modulus, of course, is a single value which represents to some extent the fineness of the aggregate. So, the fineness modulus for coarse aggregates could be 6, 6.5, whereas that for the sand that is used in concrete, it could be between 2 and 3. If it is very fine sand which is used in plaster works, it could be about 1 to 1.5. Now, coming to another example, it is put under aggregate properties, but actually it can be used for any of our calculations using absolute volumes. Here, let us try to understand the relation between quantities such as void content, water absorption, bulk density, and specific gravity. This, let us say, is the total volume in a container which is available to us. If this volume has particles of a certain size. Of course, for the sake of simplicity, in this case it is showing only particles of a single size, but that could be different. Now, the void space in this is now getting filled with some smaller particles, and if they have properties in terms of water absorption and so on, then if we were to fill this container now with water, all this space which is shown in red would be occupied by water. In this case, all this space shown in red would be occupied by water. Now, depending on whether or not we are making the assumption that these particles, whether it is these larger particles here or it includes our smaller particles here, whether these particles will absorb the water or not, the amount of water that goes into this container would be different. So, if these aggregates or these particles were dry and we try to fill the voids with water, part of the water will be used to fill up these voids within these aggregate particles, which may also be called intra-aggregate voids, and the remaining of course will fill the voids outside, which is the inter-aggregate voids. Now, as far as specific gravity and bulk density is concerned, specific gravity is the density of this material itself, whereas bulk density is the property of the material measured in bulk. That is, if we were to use the weight of this container and divide it by the volume of the container, then what we will get is the bulk density of this aggregates. Whereas, if we determine the absolute volume of these particles and then divide it by not the volume of the container, but by the absolute volume of the aggregates, what we will get in that case is the specific gravity. So, once we understand these concepts, we can be given a numerical problem, or we can approach the issue numerically and try to determine one of the quantities or more which need to be determined. Coming to yet another example of what has already been done in this course, we did the Bogues equations, and what the Bogues equations do is to help us evaluate or understand the composition of cement in terms of the solid complexes C3S, C2S, C3A and C4AF, depending on the oxide compositions in terms of calcium oxide, silicon oxide, aluminum oxide and so on. Now, remember that we talked about two sets of Bogues equations to be used depending on whether the A by F ratio is more than 0.64 or less than 0.64. So long as we keep that in mind, given the oxide composition and given the Bogues equation, we can calculate the amounts of C3S, C2S or whatever quantity is required. Now, going to another example, this is the standard questions that we have been giving in the assignments. What we have tried to do is to give two statements and ask you to find out if both the statements were true, both the statements are false, one of them is true and the other is false, and similarly this will have two combinations, the first being true, the second being false, and the first being false, second being true. So this is a standard format that we have been using in this course for all your assignments. But obviously this is not the only kind of questions that can be asked, and we can't talk in terms of numbers as we have seen just now in the examples given above. I will try to upload for you a handout which will have some of these problems and their solutions to help you better understand the concepts and also prepare for the exam better. For example, in this particular case, in the context of low heat of hydration cement as defined by Indian standards, A, the maximum heat of hydration is given only at 7 days, and B, the minimum initial setting time is given as 60 minutes. Now, if you remember the specifications or you remember the discussion that we had in the lecture, the maximum heat of hydration is given not only at 7 days but also at 28 days. So this statement is obviously false because of the presence of this word only, and this statement is true, and therefore this is the correct answer. So in this type of questions there is obviously a unique answer. However, if we look at a problem like this, where the question was, which of the following is not a hydration product? CSH gel, calcium hydroxide, ettringite and gypsum. Obviously, the answer is gypsum. The rest of them are all hydration products. In this case also, there is only one right answer, but there can always be a situation where two of these answers is correct, and then you have to be careful about having to mark both of them in order to get full credit for the question. Now, with this, we have more or less run over this overview in terms of revising our understanding and going through some of the questions in home assignments and others, which will help you prepare better for the examination. And I would request my colleague Professor Harish, who has been an equal partner if not more, in fact I think he has done more lectures than I have, to go through the summary of topics covered in the course and also give closing remarks as far as we are concerned in this course. From my own side, I would only mention that in certain cases it has not been possible for us to include all the material that is required for you to appreciate a subject completely. In an online course or in a situation where you are expected to do a lot of reading on your own, we will have to live with that, because you can always go to the sites which have been suggested, try to look at material which has been suggested, perhaps a lot more material is available on the internet, and try to come up with the solutions or try to understand the problem and try to find a solution. And with that, thank you so much from my side, and now I will invite Dr. Harish to take over and close the course. Thank you.
Good morning to everybody. Now that this is the last lecture, lecture 40, I am just summarizing what we have seen so far in the 40 lectures. So, first of all, the course on hydration, porosity and strength of cementitious material is a very carefully designed course for civil engineering students. The prime focus is on cementitious materials, which primarily includes Portland cement, water and mineral admixtures. In other words, cementitious material can also be referred as Portland cement based materials, and the use of chemical admixture is again optional. What we have seen in Portland cement based materials is that the material is significantly popular during the last 10 to 15 years, and it is critical for engineers, primarily civil engineers, to understand how the macro level properties such as strength, workability and durability are evolved from the hydration process. In addition, it is also important to understand what properties or factors are critical when it comes to the micro level, and also what relationship exists between the different properties all at the micro and as well as macro levels, and several others. So, during the first 3 lectures, the course started off directly with strength, durability and workability of concrete. Since the subject area is very popular and interesting and many times taught well in several other institutions. However, the fundamental concepts of the cementitious materials are very closely related to the properties of individual ingredients, which has to be focused substantially. So, many institutions fail to do this, and so making it difficult for students to understand the fundamentals. So, in lectures 4 to 10, substantial emphasis was on the cement production process, physical and chemical properties of cement, aggregates, chemical admixtures, and again mixed design of concrete and their importance to the properties of cementitious materials. And the student should realize that without studying these properties, primarily the physical and chemical properties of individual ingredient, it is extremely difficult to understand the composite as a whole, and in our case it is cementitious material. So, through these lectures it is expected that the students would have understood that very many factors are involved in the production of any material that you have in cementitious material, and very many properties or factors from materials can substantially affect the composite as a whole. So, in the next 10 lectures, that is from lectures 11 to 20, we focused on Portland cement based space systems, where the cement hydration process is explained in detail, which also included cement chemistry, reaction of compounds, chemical reactions, hydrated compounds, formation or development of compounds with time, degree of hydration, gel to space ratio, and others through cement hydration models and volumetric relationship. So, we believe that these set of lectures would have provided substantial information about the micro level properties or factors that are expected at the academic level. However, when it comes to choosing a particular composite and or materials or composite, the performance or properties alone is not enough. The economic and constructability related factors also come into picture based on the application for which the composite is chosen. So, in lectures between 21 and 30, the focus has been more towards sustainability and use of mineral admixtures for improving the sustainability of concrete. Fly ash, slag and silica fume are extensively available in India or in any other country for that matter. Due to the constant use of raw materials such as coal, iron, copper, silicon ores, etc., and hence when it comes to use, again their physical and chemical properties gains significance. So, that is extensively covered in lectures between 21 to 30. So, these lectures we believe would have made students to concentrate on the properties of mineral admixtures and their importance in cementitious material. In lectures between 31 and 40, the focus was primarily to show the distinction between paste and concrete. So, discussion about the presence of aggregate and interfacial transition zone gains significance. After this, other related topics such as characteristics of interfacial transition zone, types of Portland cement and special properties, porosity and permeability tests for paste and concrete and others were discussed. In addition, the importance of strength, curing, stress strain curves and durability requirements are also discussed. So, with this the summary is getting over. I just wish to provide you some important points to remember, especially while you learn, read and understand slides from this course. So, points to remember, there are 5 different things. One is the teaching style or a strategy of lecturers who are there in this course, which is primarily myself and Professor Sudhir Mishra. The second point is understanding the generality of the course. Third one is self interest and self learning. Fourth one is reading from other sources or references, and fifth one, some errors in assignment questions. So, let us discuss each one of them little more in detail. Firstly, teaching style or strategy of lecturers. What I am suggesting to students is actually not to look into the teaching style or strategy of lecturers. While some lecturers tend to read what is present directly from the slide, students should understand there may not be very many things that can be explained from those particular slides. That is one of the reasons why we directly read from the slides. And some lecturers tend to actually do it otherwise, in the sense that they without reading the slide they tend to explain it. So, in this course what is important is the slides are carefully provided in some sequential manner to facilitate easy learning. So, you will have to understand this, or you will understand only if you spend substantial time with each slide. So, if you expect that you want to learn everything merely from our teaching or through these videos, then you are not matured. You have to know that whatever we are providing is only some material, and you have to also read through other reference material to score well in this course and to gain more knowledge. We expect the students to develop self interest and self learning. Okay, this is all that I wish to say to you in the first point. The second one is understanding the generality of the course. Remember that the subject discussed in this course is largely theoretical, and hence very many things have to be remembered at the same time. So, this makes the subject too diverse, and you will basically land up in one or each of the following. Either certain slides may be too general, or certain slides may have less focus, and certain slides may have much larger focus. So, each and every slide has its own importance. So, the extent of generality of the subject areas in each slide while learning will what provides you to understand all slides. So, what I am trying to say is that you have to understand each and every slide, for which you need to spend substantial time. So, the bottom line is that spend substantial time to understand each slide during the learning process. Now, the third one is self interest and self learning. Your interest in this course should not be affected by our teaching style or strategy of the lecturers. Rather, what we would like to say is that a bright and successful student is expected to be patient, listens and develops his own strategy through self interest and self learning. We believe that the slides presented in this course will help in learning and perceiving concepts better. Okay. So, that is about the third point. And the fourth one is reading from other sources or references. We recommend that you read from very good sources. Some of the reference materials are already shown in the first slide of pretty much most of the lectures that we have presented. So, your purpose in this course is to learn and understand what is provided in the slide. Some textbooks are extremely good, and that is one of the reason why some of the figures that we have chosen are directly from the textbook, so that it helps the audience to learn quickly and immediately the fundamental concepts. So, selected photographs are provided for explanation from textbooks and other codes of practice. Please also learn from other sources and references. And the fifth one is errors in assignment questions. What we have noticed over the last couple of weeks is that some students had raised queries in few assignment questions, particularly the choice of answers and other discussions. We received all queries, and the assigned teaching assistant would have already responded to you by now. We generally notice that there are few errors in the questions out of 40 or 50 questions, assignment questions that we have provided to you. And we will make sure that these errors do not happen in the final exam, and it is expected the students shall concentrate on the lecture videos very carefully. And with this, I am wishing all the best for the final exam. And if you have any doubts or questions, please email to us, but make sure that when you email, do not email at the neck of the time. Whenever is your exam, email at least a week or two before the exam, so that we have sufficient time to respond. With this, I am completing. Best of luck one more time. Thank you.